Chris Wright, he is the Vice President and Chief Technology Officer of Red Hat. An exciting look of RHEL 8 comes up next. Chris, thanks for taking the time to sit down with us. We appreciate it. Obviously, Red Hat has a vast and wide array of lineup of services and products that you guys are working on: RHEL, OpenStack, Kubernetes, OpenShift, Istio. Give us a rundown and an overview of what these changes have been over the last 10 years.
Well, I think a huge shift over the last 10 years has been around transitioning from a single server to what I would just say distributed systems. So if you go back in time, Linux was the platform. Linux was a platform for applications running on a piece of hardware. Now we started to virtualize that hardware, but initially that was really very similar looking to a server environment. So the application and the operating system inside the VM were maybe lifecycled together, maybe even custom artisan handcrafted snowflakes. And so over time, you saw the cloud come in, create an immutable image, start to separate a little bit of the content, the application content away from the OS. Containers really formalizing that separation between application, runtime dependencies, and the operating system. And all of this is to really improve the speed at which you can build and deploy applications and do it at scale. So to me, what we've done from a Red Hat point of view is think beyond just RHEL. I mean, if you go back in time, I've been at Red Hat a little over 13 years. When I started to help Red Hat become a virtualization company. So at that time, we were just RHEL. We started to add middleware and add hypervisor support, and over time, we've really built up this entire portfolio around scaling applications distributed across multiple different types of deployment footprints, like a public cloud, multiple public clouds, on-premise in your data center, and kind of looking forward even out to the edge. So that our view is hybrid cloud, our product portfolio is supporting that. And to me, it's kind of, well, we're building distributed systems. You need the right tools to build rapidly and deploy rapidly out into that complex environment.
A lot of those tools are found with things like Kubernetes and OpenShift. How do you see that evolving over time?
One of the really cool things about Kubernetes is, if we take it back to Linux single server, Kubernetes distributes Linux. And the reason I think that's important is, number one, look at the success of Linux. It's been around for over a quarter century. Why is it still going? Like, what's happening there that's unique, that keeps it fundamentally a huge part of our entire industry? I think it's about the vast number of different types of workloads that run on top, and the crazy array of hardware that it supports underneath. So it's created this abstraction, it's evolved with all of the different changes in hardware as well as application needs. And that's for, again, predominantly like a single server. Kubernetes, distributing Linux out to broad scale, gives a new kind of platform target, but the important thing to me is it's an industry-wide platform target. And what's, I think, unique about this is it gives that same kind of longevity into the project where the whole industry starts to rally around that. It's the independent software vendors, it's other open source projects, it's just everybody thinking in terms of, okay, we're going to containerize and we're going to distribute. And that's a really powerful way for the whole industry to collaborate.
When I started my IT career, I was working with clients to implement thin client solutions. So the idea was that we had central power, and then we had these basically dumb boxes that connected back to a central power station. My career progressed to the point that we started to see that power localized into the individual user's desktops. And then we had a period of time where everything was running on a desktop. Interestingly enough, just in the past few years, what I have seen is clients coming to me and saying, hey, I want to utilize and take advantage of virtual technology so that we can, so essentially we can divvy up these computers because they're so powerful that no one person actually needs a whole computer. And then now we're seeing people actually use dumb clients to establish remote sessions back into a virtual host. I'm curious what you see the evolution of that is. Are we going to get back to a point where we have centralized computing and essentially the end terminal is just kind of a dumb thing that talks to something as a service?
So it's important to look at history, right? And it's easy to take a snapshot and then assume, certain trajectory. History says, okay, computing's been, it's decades. And you look back at a mainframe and a remote like VT100 terminal, and I guess you could call that a thin terminal.
Yeah.
Pretty thin. And then, we evolve, we get client server, the clients get fatter and fatter. And then a round of, okay, we're gonna do thin clients and put all the intelligence on the server. And then meanwhile, the client computing side gets richer and richer. And okay, we'll fatten up the application. So I think it's just this kind of continuous cycle. And, I think that we'll keep seeing shifts. And right now, we've been moving functionality out of the application onto the server side.
Right.
And I'd say that's largely driven by phones, like not necessarily that they're low power, because by those kind of mainframe days, it's a supercomputer in your pocket. But the simplicity of the interface, the kind of keeping the apps really clean, that's been driving some of the thinking. And, but then you start pushing more and more JavaScript to the phone or to the client side. What I think will happen is power consumption on your device will really matter. As apps get more and more complicated, they become more power hungry. As you have more compute moving to the edge, you have a place to offload functionality from your phone to a low latency connection, one hop in the network. So I think we're just gonna keep seeing this sort of ebb and flow of hardware architectures and software patterns and use cases moving between how much do we put on the client and how much do we put into the server, where the server may not be always centralized. It could be distributed at the edge.
Do you see the internet becoming so ubiquitous, having anything that plays into that as well? The fact that we have internet basically everywhere we go, Wi-Fi is everywhere we go, and so before we almost had to have localized computing environments, because if you were going to edit a document or write an email, you might have to do that locally and then send it out once you get connectivity. Obviously that has changed. Does that play into this?
Without a doubt. I mean, there's an expectation for total connectivity. Now, it's important to remember that the whole globe isn't covered. So we still have this digital divide, and it's a really important socioeconomic thing to consider about how we evolve as humans on this planet. But that ubiquitous connectivity, I mean, again, go back to the phone, you just expect that you're always connected, whether it's on Wi-Fi or whether it's through your cellular service provider. And with 5G, I think we'll see just that continue to grow. I mean, this expectation that you can have high bandwidth, low latency connections always is important. The connectivity consistency isn't always the same, depending on whether you're cabled or whether you're going, if you're mobile. And so the need to have applications that can have some level of functionality without being connected, I don't think goes away. And when we look at some forms of edge computing, there's actually an assumption, like take a store, for example. There's an assumption that the store needs to, if you're pushing some functionality out of your data center into the store, you probably are in part assuming that the store may not always be connected. So if you had some crazy system where you couldn't open your doors because you lost your connection to your data center, that would be no good.
Right.
So I think we're going to have more and more expectations around connectivity, but we'll still have systems that pay attention to functioning when they're not fully connected all the time.
As security becomes more and more of a focus for businesses, do you see something like Linux VServer becoming a focus for RHEL?
Interesting. I used to work on Linux VServer a long, long time ago. So I would say security, super important for Red Hat, for our customer base. VServer as a way to do an implementation, I would put that closer to a type of isolation that we do today with containers. So containers are important. The way we build containers is, one, there's a couple of kernel primitives that allow you to isolate namespaces and manage resources associated with that isolated namespace. That's the core of a container. What we do at Red Hat is we wrap a mandatory access control policy around that container to really improve the security stance of what's running in the container versus the host. So we'll continue to do work like that. Super critical that we have the right kind of security risk profile for our customer base. The technical details, is it vServer? Probably not. It's probably really just containers augmented with mandatory access controls, and even filters, syscall filters like seccomp, so you can limit the number of syscalls that a single container could make down to the host level. And then there's probably opportunities to get connected to underlying hardware isolation mechanisms. We did that 100% for virtualization. There's a couple of attempts at that in the combination of virtualization and containerization. They're still a little heavyweight, so I think there's some opportunity there that we haven't quite tapped into yet.
AI is a very disruptive technology, and we're seeing it becoming very ubiquitous and very prolific. What is Red Hat doing to position itself to provide the best experience for its customers?
It's a huge workload. We see it across all of our customer base. What we're trying to acknowledge for ourselves is, number one, we're not here to write the next most amazing AI framework. It's not our core competency. However, all of these frameworks are being written in open source communities. And so we pay a lot of attention to the different projects that are associated with machine learning. Our focus is onboarding those onto our platform and then ensuring that they get kick-ass performance. And you look at hardware accelerators, well, what's in charge of hardware? An operating system. So we focus on the hardware enablement and then making that hardware accelerated runtime environment accessible to a virtual machine with OpenStack, a container with OpenShift, so that applications, machine learning, model training applications, can take advantage of that accelerated runtime. And then we work with a partner ecosystem that have more specialized expertise in specific models or some of the frameworks, so that we can really support our customer requirements, which are, they've got a lot of data, they want to stream that data in, do training, model training, build models, deploy models for inference, connect those inference engines to applications so that applications are smart, they're contextualized, they're personalized, they're giving good recommendations to the end user. So our view is we're a platform company, and we want to support those workloads, and we want to make sure they run with great hardware optimization.
Is there a point where you see Red Hat developing their own UniKernel module?
It's a great question. Now, one question is, what's the use case? So we kind of got to understand what problem are we trying to solve. So UniKernels tend to be a mechanism for accelerating applications when you're running them in, say, a virtualized environment or maybe even in a serverless context. So far, we haven't seen a huge amount of commercialization of UniKernels. And if you look at some of the different projects out there, they are not always derived from Linux. In many cases, they're custom-built UniKernels. What we've been looking at is how could you take Linux and turn it into a UniKernel? And so we've done some work with some researchers actually here in Boston, at Boston University, where with literally about 10 lines of code added and about 20 lines of code modified in the Linux kernel, and then 1 line of code per system call in glibc, we've been able to make a new environment where you can compile the kernel, glibc, and your application together as one static binary. And the reason we think that's so important is if UniKernels are going to be a thing or not, if they're not built from Linux, you're going to really struggle to maintain that velocity of feature functionality and kind of application compatibility.
Absolutely.
So this is what we're looking at. And again, we have to understand the commercial motivations and what does it really look like from a customer point of view. But we're doing the technology exploration right now to figure it out, and it's turning out to be really cool. Even a lot of work, but in the end, relatively unintrusive in these core projects, glibc and the kernel. And probably an important open question is, how do you debug such a system? So I think we're so used to an operating system and an environment where even though we recommend against it inside your container, people still want to SSH in and go see what's going on.
Sure.
And you're not going to be able to do that in a UniKernel unless you have some crazy KSSH kernel module that's compiled in there, and that just doesn't really even make sense. So how do you get the instrumentation, visibility into the application, debugability, so it's usable, plus all the acceleration, performance gains that you'd get. So we're focusing right now, performance, we got to look at usability and then understand like the commercial viability. So long-winded way of saying we're looking at it, we don't know where it's going.
Makes perfect sense. With the push for virtualization and companies wanting to do that to get a better bang for their buck out of their physical hardware, are you seeing anybody push back on that and saying, I'm not willing to retool my infrastructure to move from a physical server to a virtual machine, or is that not really an issue?
Well, that's an interesting question, is like right now. So if you'd asked me that very same question even just a year ago, I would have said, no, everybody's all in on virtualization. What we've seen in the last year, maybe a little longer, Kubernetes has really taken off. It's completely won the container orchestration platform. Some of our customers are starting to say, why run that in VMs? Why not just run it on bare metal? It's got Linux. Linux runs on bare metal. It's been running on bare metal for decades. So we've actually been investing in that. And here at the Red Hat Summit this week, we announced a product we called around this technology we call KNI, Kubernetes Native Infrastructure. So we're looking at deploying Kubernetes to bare metal. You get the same consolidation capabilities or benefits of virtualization. And in fact, we're working on a project, an open source project called KubeVirt, which brings virtualization support on top of Kubernetes. So now you could run a single orchestrator spread across a number of hosts, managing containers and virtual machines, all as peer citizens on the same platform.
Wow.
Which is pretty cool. Where that goes and exactly how that gets, what kind of enthusiasm develops around that, that'll remain to be seen. But yes, I think it's not resistance to virtualization, but it's now saying, well, if I'm going to deploy a container platform, do I have an opportunity to take a layer out of the stack and really just run containers in bare metal, and then maybe even somewhere down the road, I have a way to onboard some virtual machines into that same orchestrated, distributed platform.
So from your perspective, personal opinion, is this a function of just lowering overhead? I don't have to manage updates for 5 systems. Now I just have the one central physical machine to update, and I still get process isolation. I still have security. I still have modularity. Is that the benefit there?
Yeah, I think that's really it. It's about simplifying. If you think about what we're doing today, we're building more and more complex systems. So while we're doing that, we have to look at any opportunity to take complexity out of the system. Certainly with complexity, we're adding automation so we can manage complexity, especially at scale. But hey, if we have an opportunity to reduce some layers, it's definitely worth looking into. And there's, the different question would be, are there performance optimizations that you gain, or performance improvements that you gain by removing a layer? Certainly, virtualization adds some overhead in the I/O path. So if you're running a container workload in a VM and you move that to run directly on the bare metal, you're going to remove some of the virtualization overhead for the I/O. Compute-bound tasks, it's really not an issue. So I think there's some questions around, is there a performance benefit? And certainly anything you can do to simplify complexity, good thing for operations.
Absolutely. Make it more modular and give more control back to the individual user. I love it. What has brought everybody together this week is open source, right? It's not a tagline, it's not a brochure filler, it's what everybody I've talked to at Red Hat seems to hold as a core belief. To you personally, what does open source mean?
Well, first of all, open source has really given me my livelihood, so I have to be really thankful. But open source means a handful of things, really specifically. It means it's a development model, it's an engineering practice, it's a way to build software, it's a way to interact with a broader community. To me, an open source community is, number one, a place where collaboration happens. It's collaboration around a shared vision. So you've got this idea, you want to work on it together. It's collaborating around a shared vision with people. And what's important about that is we're developing human trust relationships to actually get work done. It's not about like some legally binding this or that. It's totally about people and how we relate with one another. It rewards people who take initiative. So all you have to do is show up and do something.
It's empowering.
It's totally empowering, and that's what got me involved. Like way back in the beginning, I showed up, I did something. Hey, they even accepted my patch, like what a rush that was, and I'm still
let's dig into that. Let's
fired
dig
up
into that a
about
little
that.
bit. So everybody has, and I know I did, right? I started out in proprietary technology. I came over to the open source side because I had an aha moment. I had a light bulb, and I hit a brick wall. I couldn't install Windows one more time. I couldn't install drivers or deal with the blue screen one more time. And so I looked over to open source and the way that they were approaching problems and the way that they were dealing technology and the way that they were putting the power back into the hands of the user rather than a corporate interests. What was the aha moment for you? What point did you go, that's what I want to spend my life doing, is promoting this way of developing software?
It was, I mean, to put a relatively fine point on it, probably about 20 years ago. And I was working in a project. I was actually responsible for the high availability of a platform for the company I was working for. And this responsibility was actually a little frustrating because it ping-ponged about once a quarter between go build something and go buy something. And I was kind of going crazy. And along the way, I found this project in open source that was doing high availability. And I got involved, and I found that, number one, the people that I was communicating with were just brilliant. And I was relatively new to this space, so I had an opportunity to talk to the smartest people on the planet around this fascinating topic to me. Not only did I have that opportunity, but they took the time, like they cared, and they shared their experience with me. And ultimately, I was able to get involved and submit a patch. And it was submitting the patch and having that patch accepted and that whole process of engaging with this amazing community that was the aha moment. And like I was hooked, and kind of coincidentally in time, my roommate brought home the GNU Manifesto. I realized there's more of a social political movement involved with open source beyond just the technical capabilities of building software together collaboratively. So I was totally hooked at that point, and I'm still hooked. I mean, I love it.
Me too. Chris, thanks so much for taking the time to chat with us. We really appreciate your time. We'll get you back on the program soon.
All right, thank you.